Okay, so we're on example 2 here. It says in the diagram below, segment DB, right here, bisects segment AC. Find the length of BC. So we're going to say up here, we're trying to find PC. We're going to leave that there. Okay. This will be, you can put a box around it if you want to. This will be our final answer. Okay. Now we know from the first part of the notes that AB will be congruent to BC because DB bisects that segment. Bisect meaning cut in half. Okay, so when you see it bisects, that means it's cutting it in half. So we can say that AB is now equal to BC. Let me get this focused. There we go. Okay. So then AB is equal to 4x minus 5, and BC is equal to 11 plus 2x. So now that we have an equation, we can solve for x. So we're going to subtract 2x from both sides. So here we have 2x minus 5 equals 11. Oops, I don't know why I changed that to a plus. We're going to add 5 to both sides. We're working on getting x by itself. Okay, and then we'll divide by 2. So we end up with x equals 8. So that's good that we found that, but that's not what we were asked, right? We were asked to find the length of BC. So we know that BC is 11 plus 2x. So if x is 8, we can just plug 8 in. So we get 11 plus 16, 2 plus 8 is 16, and this would give us a total of 27. So BC is 27. Okay, there is a special type of bisector. So sometimes we'll have that segment bisector, but there's an even special kind of version of that called a perpendicular bisector. Okay, a perpendicular bisector is is a line or segment that intersects a segment at its midpoint. So really, it's very similar to this, but there's one thing that is different. For a perpendicular bisector, it creates a midpoint, but it also is perpendicular, meaning it creates a right angle. So if you look right here, it says in the diagram at the right, MN and PQ are perpendicular. We sometimes use the symbol that looks like this. It's like an upside down T to show that two lines are perpendicular. For example, in this case, MN is perpendicular to PQ. And to show that it's perpendicular, we usually do that little symbol for a right angle there. Okay, let's take a look at an example. In the diagram below, CD is a perpendicular bisector of AB. So here's what this means. Okay, right here, that tells us that we have right angles. Okay, every angle is right. We could actually kind of, call all of those right angles. And then also, if it's cutting AB in half, that means that we have AD congruent to DB. So let's write that down. Okay, angle COB is 90 degrees. Okay, and all of the rest are too. You don't have to write these down if you don't want to. Angle BOD is 90 degrees. Angle DOA equals 90 degrees. And angle AOC equals 90 degrees. Okay? Now, we don't always have to write that down. This is just the note, so I want to make sure that you know all of those are 90 degrees. As well as we also know that AD is congruent to BD. Oops. BD. Okay. So if the measure of angle COB is 8x plus 50, 8x plus 50, okay, that's this angle right here. Let's stop there. Let's stop there for right now, okay? We know that angle COB is already 90 degrees. So instead of writing COB, let's write 8x plus 50, because 8x plus 50 is COB. Okay, let's not write our degree symbol for this solving here. Okay, so if we do 8x plus 50 equals 90, we can solve for x. We'll subtract 50 and then divide by 8. So x equals 5. Okay, then it tells us that AO, oh, I'm sorry, that wasn't D, it was O. AO is y minus 7, and BO is 11. Well, if AO equals BO, set them equal to each other. And then we can solve for y by adding 7. Okay, now let's make sure that we have everything we needed. It says right here, find the value of x and y. And we did that. We have x and we have y.